0. All right, so we're going to take a look at this PARCC Release problem about the water costs. The math behind this problem is not very difficult. You all can do it. But it's the steps that are not talked about that makes this a tough problem. So let's go through. We're going to read the problem. We're going to pull out important information, and then we're going to discuss about the information we need to discover in order to solve the problem. That's what we're going to do. Here we go. The Water Watch program is encouraging customers to reduce the amount of water they use each day. The program is selling low-flow shower heads which use 2 gallons of water per minute for $54 each. A family currently has a shower head that uses 5 gallons of water per minute and is considering replacing it with one of the low-flow shower heads. The family uses the shower an average of 20 minutes per day and pays $0.002 per gallon of water. So I need some help. What are the important pieces of this problem? What are the important numbers that we must use in order to solve this problem? Louis?
5 gallons.
5 gallons. And this 5 gallons represents the water that we are saving, going to use with the new valve or using the current valve. Which one?
The current valve.
That's our current valve. Okay. Another piece of important information, Stephen?
How long they shower a day?
How long they shower a day. Wouldn't you love to take a 20-minute shower?
Sure would.
I take one. I do.
Okay, many of you do. Okay, we will not let other people know that though. So it's 20 minutes per day. All right, what other pieces of information will be important to solving this problem? On to the girls. Phoebe? Okay, so it is going to cost us $0.002 gallons, dollars per gallon. Okay. What else will we need to know? Caden?
The 2 gallons of the low-flow shower head.
Oh, and we have a 2-gallon low-flow shower head. So out of curiosity, what is the difference? How much water will I save each minute? And that's the first math problem. What is the amount of water I'll save each minute with my new low-flow shower head? Clay?
3 gallons of water.
So we're going to save 3 gallons of water per minute. Okay, and that's an important piece, and we're missing one last thing. Ballard?
The fact that the shower head costs $54.
So we are talking about money saved, and I'll read this in a second. Is the $54 cost for the shower head a positive or a negative if that's what we have to pay for it?
Negative.
It's negative. All right. So we've pulled out all of the important information. We've done a little bit to find the gallons per minute saved. Now it's time to look at the real problem. And the problem says, create a model. We'll talk about model in a second. Create a model that can be used to determine the cost savings in dollars for the family to purchase and use a low-flow shower head in terms of the number of days. Then, determine the number of days at which the family will start saving money. Justify your answer in terms of the context. And then enter your model. So this is a fill-in-the-blank problem. Enter your model, answer, and justification in the space provided. Now your justification is essentially showing your work in an organized manner so that any person who is mathematically literate can follow your steps. Or you can write a paragraph. Your choice. All right, so model. Let's talk about this word model. There are 3 different types of mathematical models that you can use, but only one of them will fit in a fill-in-the-blank. So let's talk about the 3 models first. What is one of the models that is possible to use? Aiden?
A graph.
A graph. Is that going to fit in the fill-in-the-blank?
No.
No, so we're not talking about that. Kathleen?
A table.
A table. A table is also a mathematical model. Will that fit in the fill-in-the-blank?
No.
No. Not in the computer fill in the blank there, buddy. So we are left with our third model, and that's the only appropriate answer. Allie? An equation. This has to be an equation. The mathematical model is an equation. So that's the first piece of vocabulary. So if this is an equation, we need to determine the type of relationship. In 7th grade, you've only really talked about one type of relationship. In 8th grade, you've talked about 4. What kind of relationship is this? Braden?
Linear.
This is linear. Your model is going to be in the form of y equals mx plus b. So we are looking for a slope and a y-intercept. You know that is true. Also, instead of using x and y, I would like to use variables that fit the context of this problem. What is y going to be?
Total cost.
Money.
Money saved. So m is going to be money saved, and that's our y value. So then we're going to have a slope. I'm going to do my fill in the blank. This, and we'll talk about slope in a second in this context. And what is x going to represent in this problem? What is x going to represent in this problem? Days. The number of days you've been using your new low flow shower head. And then we're going to have our y-intercept. But we already have our y-intercept. It's that negative $54. Because we're going to have to figure out how long it takes to pay back that $54 that we spent on the actual shower head. All right. So now we're getting somewhere. We know what the model is going to look like. We have half of the model already filled in. Now it's about the slope. The slope. What is the slope in this context going to mean? Clay?
Amount of money paid per day.
Amount of money saved per day, because we're trying to find savings. So the slope is the amount of money saved every day. So what do I need to do to figure out the amount of money that I save every day? What information must I use to get to the amount of money I save every day? And that's the hard part, because it is not written in this anywhere. You need to do this. Trevor?
You'd have to multiply the gallons.
So how much will we save per day?
You'll save, it's 0.02 cents per gallon.
Okay, so you're starting with the cost.
The cost per gallon. And
Okay.
then you do 2 gallons per minute.
No, we're saving.
Oh, 3 gallons per minute.
Okay, so hold on a second. So this is going to be the amount of money we save per minute. So this is savings per minute. So let's multiply together, and what do we get?
That would be 0.006.
Okay, sorry for the bad writing there. So we are saving $0.006 per minute. Times
20.
times 20. Why are we doing it times 20?
That's how many minutes you shower each day.
So we have to find the savings per day. And so we take that 0.006 and multiply it by 20, and we get 0.12. So you save 12 cents a day. And that's our slope. Again, the math involved in this problem is not difficult. Everyone here can multiply. Everyone here can find a linear equation. It's putting the pieces together and figuring out what you need to do to get there. That is the difficult part. On PARCC, there'll be nothing you're given that you cannot do mathematically. I guarantee it. All right. So then it asks, how long will it take for us to start saving money? Well, what will our m value be when we have hit that break-even point? 0. Oh, okay. That's easy enough. So we have a green 0 for money is equal to 0.12d minus 54. Oh, that just looks like a problem you've been doing for the last 6 weeks. Go ahead and solve it. Yeah. So we get 54 is equal to 0.12D. Divide by 0.12, divide by 0.12. And so we get D is equal to?
50 days? Oh, I guessed it. You have to wait a year.
That's more than a year, buddy.
Well, I know, but like,
Yeah. So, again, there's nothing in this problem you can't do. Nothing. It's the pieces that make it hard. So let's take a look at problem B. 1 year after the low flow shower head is purchased, and that's going to make this problem difficult. The cost of water is increased by 5%. Create a new model. Now you'll recognize model being equation. That will determine the cost savings in dollars with the increase in the cost of water. Use your model to determine the number of days at which the family will start saving money after the increase in the cost of water. And so this is after the increase, so they're not including that first year. So we know that our model is going to be in y equals mx plus b form. If I'm saving 12 cents per day and I'm now paying 5% more, what will I do with that 12 cents so that I figure out how much more I'm going to save because the price of water has increased? Trevor?
you would multiply the original cost by 0.05.
Okay, so I'm going to multiply it by 0.05. Now you'll notice I left a blank here. Why do I want it to be 1.05?
You still need to include 0.12.
Okay, when everyone's talking at once, I can't.
It
Colin?
automatically adds with 0.12 into it, so you don't have to add the 0.5. The 5/100ths of the 12 onto it.
That's exactly right. This one represents the 12 cents you had to pay originally. This 0.05 represents the increase. So when you multiply this together, and I believe you'd be allowed to use calculators in this problem. When you multiply this together, you get a grand total of?
0.126.
Oh, we have our new slope. So m is equal to 0.126 times the number of days. And now it's an issue of the y-intercept, and this is the tough part. From my original equation up here, how long did this original equation work?
1 year.
1 year. How many days are there in 1 year?
365.
365. So we're going to have to do m is equal to 0.12 d minus, come on, it's thinking. It's going to erase this eventually. Just don't crash. Okay, minus 54. And what will I substitute in for d? 365. Okay, so we have m is equal to 0.12 times 365 minus 54. Oh, you know how to do this, right? So, no, because this is in the first year that top equation worked. So we need to figure out how much we've already saved because we still have more saving to do, right? Okay. So what's 0.12 times 365? Well, I can pull up a calculator. 0.12 times 365. Okay, so I have $43.80. I've already saved $43.80 in 1 year. Not bad. Minus 54. So now what will I do? Subtract 54. Oh, what's my new slope?
Negative 10.2.
Okay.
That's way less.
Well, because you have $10.20 more to save. So when we break even, what will my m value be?
0. 0.
0.
Oh yeah, what is it?
And so now it's just like the previous problem. And ultimately, what I'm going to be doing is I'm going to be dividing 10.2 by 0.126. And so D is equal to
1.26 or 0.126.
Is it 80.95?
I'm going to round that to 81 days. So the math involved in this problem is totally doable by everybody in this room. The steps, figuring out the steps, that is the truly hard part.